Lastly, we'll look at these producer's surplus versions. So these are essentially the same in terms of their approach. The only difference here is that in these problems, you're integrating from 0 to x1, but in order to compute the area that corresponds to the producer's surplus, you need to take P1 minus the supply curve and integrate that. So that's the formula that appears above, and that's what we're trying to apply here. So it says find the producer's surplus at a price level of P1 equals $299 for a price supply equation of S of X is equal to 29 plus this stuff. So here, remember that this is representing the price at which X units would be supplied. So this is our price for the suppliers. And therefore, if we want this equilibrium quantity, we need to do the same thing that we did in the previous problem. So we're going to find x1, the equilibrium quantity, by setting P1 equal to that supply price. So that would tell us that 299 is equal to 29 plus 0.003 x squared. What this is doing is it's computing the intersection point between these two curves. And graphically, what that means is that I'm looking at this dotted line P1, and I'm looking at the supply curve S of X, and by setting them equal to each other, I'm figuring out where they intersect, and that happens at the point x1. So that's how we're finding x1. And then once we find x1, we'll be able to integrate the difference between these two curves to find the area that we want. So I'm setting them equal to each other, we get this equation, and now I'm just trying to solve for x, because that will tell me this equilibrium quantity that we're looking for. So I would subtract 29 from both sides. That would get us the new equation, 270 is equal to 0.003 x squared. And then dividing both sides by 0.003, what I'll end up getting is 90 grand. So I just plugged that into a calculator, but it's 90 grand is equal to x squared if you divide both sides of the above equation by 0.003. And now by taking a square root on both sides, you can solve for x. What we end up getting is two options for x because we need this plus or minus, but the square root of 90 grand is equal to 300. So this would be x is equal to plus or minus 300. Now clearly we don't care about the negative 300 because you can't supply a negative number of items. So x1 is just going to be the positive root here. So this will be x1 equals 300. And now we found x1. So now we have all the information we need to set up the integral. For the integral, what we'll have is that the producer's surplus is equal to the integral from 0 to x1 of the price minus the supply curve. So we'll just plug in all of these things. So we know now that the quantity is 300. We know from the prompt that the price is 299 minus the supply curve, which was 29 plus 0.003 x squared. So I'm just plugging in P and S and the equilibrium quantity that we just found. Now again, I'm going to clean up this expression a little bit. Be careful here because when you subtract S, so when you have minus S of X, that part is going to, well, maybe I should say this minus sign is going to distribute to all of S of X. In other words, it applies to this entire expression that follows. So we do need to distribute that minus sign. And when we do that, we'll get a 299 minus a 29. So that would just be 270. And then the minus sign would also distribute to the second term, giving us a negative 0.003 x squared. So now we've cleaned up our integrand. So we can compute this antiderivative. The antiderivative of 270 is just 270 times x. Now when we take the antiderivative of the second term, we'll still have this constant out front, and then we would promote the power on x to a 3, and then divide by 3. So we'll end up getting that. And this whole thing should be evaluated from 0 to 300. And if you wanted to, you could clean this up a little bit more. Like, for example, you have a 0.003 divided by 3. So you could simplify this so that it looks like 270x minus 0.001x cubed, if that's easier to type into your calculator. But we still need to evaluate from 0 to 300. So if I plug in 300 as my x value, I would get 270 times 300 minus 0.001 times 300 cubed, minus the evaluation at 0, but notice that both of these terms will be 0 if we plug in 0. So this would just be minus 0. And now if I plug this entire thing into my calculator, what I end up getting is 54 grand. So that's how much extra money the producers are making relative to the lowest that they would be willing to sell for. So if you could go to each producer and ask them the minimal amount that they would be willing to sell for, and they had to sell for that amount, then this 54 grand is the amount of extra money that they're getting by selling at the market price instead. So here, both the consumers and the producers are benefiting as a group. So it's not necessarily that individual consumers are benefiting. There might be some consumers that would only be willing to buy it at the market price, and they wouldn't be willing to spend any more on it, right? So that producer or that consumer in particular is not benefiting. And similarly, there might be some producers who are only willing to supply at the market price and no lower. And that producer would also not be gaining anything by selling at the market price. But some producers are going to be benefiting from this. And this producer surplus is measuring the total amount that the producers overall are benefiting. So let's look at this last problem, problem 9. It's exactly the same. It's just a little bit different in terms of the price and supply function. But the strategy will be the same. So here, again, we're looking for a producer's surplus at this price point, and with the supply function 31.5 plus 0.015x squared. So remember that the formula that we're using is this one. And we already know 2 out of the 3 variable things in this formula. We know P1 and we know S. So the only thing left for us to be able to plug into the formula is X1. And then we'll know everything that we need for the formula. So our first step, again, is to find X1. And to do that, we will set P1 equal to S. So we'll just set these 2 things equal to each other. That will find the intersection point between them, which is at the equilibrium quantity. So we'll get 45 is equal to 31.5 plus 0.015x squared. I would subtract 31.5 from both sides. If you do that, you'll get on the left side 45 minus 31.5 is 13.5. And the right side will be still a 0.015x squared. And then our next strategy would be to divide by 0.015 on both sides. For this, I just used a calculator. So if you divide both sides by 0.015, then on the left side, what you end up getting is 900. And on the right side, you'll just have x squared. So now we can take a square root on both sides. We'll get that x needs to be plus or minus 30. But again, we disregard the negative here because a negative supply doesn't make sense. Or if you want to phrase it this way, it's not in the domain of our supply function. So we disregard the negative and we'll end up getting x1 is equal to 30. And now we've found x1, that's enough for us to plug into our producer's surplus formula. This is the integral from 0 to x1 of the price, which was 45, minus the supply function. And remember, you subtract the entire supply function. So this would be minus a 31.5 plus a 0.015x squared. So subtract that whole thing. In other words, this minus sign applies to the entire supply function. So now we'll clean up the integrand before we actually find any antiderivatives. So we have 45 minus a 31.5, so we've already computed that that's a 13.5. And then that minus sign will distribute to that second term. So we'll get a 13.5 minus a 0.015x squared. And now we'll take the antiderivative. The antiderivative of 13.5 is 13.5x. The antiderivative in this term is going to be a negative 0.015 times an x cubed over 3. Because we would add 1 to that power and divide by the new power, and we would also keep that constant factor in front. So this is what we get, and we're going to evaluate from 0 to 30. So this will be a 13.5 times 30 minus 0.015 times 30 cubed divided by 3. That's just the evaluation at 30 minus the evaluation at 0. But notice again that if you plug in 0 into either of these terms, they both become 0. So this will just be minus 0 when we evaluate at 0. And then finally, if you plug this expression into your calculator, what you'll end up getting in total is $270. So the producers are gaining an extra $270 over what they would have been willing to sell for at their lowest. All right, and that concludes all of the applications that we're going to be looking at. I'm not going to be collecting homework over this application section, but I will be posting some example problems that you can use for